Periodic classification of elements. The first question is, did Doberiner's triads also exist in the columns of Newland's octaves? Compare and find out. Solution. Yes, Doberiner's triads also exist in the columns of Newland's octaves. One such example is lithium, sodium, potassium. That is a triad in Doberiner's classification, and that is also present in Newland's classification. Next question. What were the limitations of Doberiner's classification? Solution. Doberiner classified elements in triads. The example of triads are lithium, sodium, potassium, calcium, strontium, barium, and chlorine, bromine, iodine. He could not classify all the available elements in triads. Hence his classification was discarded. Next question is, what were the limitations of Newland's law of octaves? Solution. Limitations of Newland's law of octaves are: one, it was found that the law of octaves was applicable only up to calcium. As after calcium, every eighth element did not possess properties similar to that of the first. Second drawback, It was assumed by Newlands that only 56 elements existed in nature. And no more elements would be discovered in the future. But later on, several new elements were discovered, whose properties did not fit into the law of octaves. Third limitation: in order to fit elements into his table, Newlands adjusted two elements in the same slot. But also put some unlike elements under the same node. Cobalt and nickel are in the same slot. And these are placed in the same column. As fluorine, chlorine and bromine, which have very different properties than these elements. Iron, which resembles cobalt and nickel in properties, has been placed far away from these elements. Thus Newland's law of octaves worked well. With lighter elements only.